Hello and welcome to What's New with CDP Public Cloud. Today we have, my name's Hannah Jetty and I'm coming to you from New York City. I'm a product marketing manager for CDP Public Cloud. And I have with me Krishna Maheshwari, the product manager for Cloudera Operational Database, and Michael Coase, product manager for DataFlow. Welcome guys, how are you?
Good, glad to be here.
Hey, yeah, doing well. How are you?
Doing okay. How's the weather out there where you guys are?
It is sunny because we are in sunny California over here.
Yeah, same here. We've had at the coast we've had a week or so of clouds and fog, but now sun is back and the pelicans are back here as well, which is always a nice thing to see them flying in formation. So it's been a good day.
Oh, that's cool. We have summer starting here, which is exciting. To our audience, let us know where you're joining us from. Drop a note in the comments. So today we're going to be talking about what's new with CDP Public Cloud, and we'll cover kind of a few new exciting features from the last month of releases, specifically around our operational database and DataFlow solutions. For those of you who are joining us live, please join in and ask us some Q&A. We have the Q&A in the chat window, and we'll be able to, we'll enter you in a raffle to enter some cool Cloudera swag. With your Cloudera swag, you can get some Cloudera socks, a nice Cloudera hat, not that useful in the summer heat, but hopefully you can enjoy that in the fall and winter, and then, or maybe a Cloudera notebook. So we've got some fun stuff out there. So don't forget to ask some questions and comment and engage with our panelists today. So let's get started. Michael, so what's new with NiFi on DataHub?
Oh yeah, we got a lot of new things with generally DataFlow in DataHub. But yeah, we can start out with NiFi. And for those of our viewers who don't know NiFi or have never used it before or are not using CDP Public Cloud right now, NiFi is an open source tool that allows you to move data quickly from A to B, specifically optimized for real-time streaming scenarios. So can do really well with lots of events coming in real time. You have to process them quickly, do some filtering, enrichment, etc. And we offer that as a DataHub template in our CDP Public Cloud solution today. So last month in April, we released the latest NiFi version. So we went up from NiFi 1.11 to NiFi 1.13, which obviously includes all the bug fixes, improvements that the community contributed to 1.13. Specifically, what I wanted to call out for our customers that they typically ask about is there's a lot of new monitoring capabilities in NiFi. So once you run your critical data flows in NiFi, you need adequate monitoring tools. And some of the things we've done in NiFi 1.13 is that we've now have, we store the status information of the NiFi nodes, we persist them, and we make that information queryable. So you can go back in time and see how your NiFi cluster health, was over time, and if there were any impacts on your data flow performance. And we also added a Prometheus endpoint to NiFi. So because a lot of our customers start using Prometheus, Grafana to monitor, and they can now connect their own Prometheus instances and scrape metrics from NiFi, and then build their own custom dashboards and get really into the details of the metrics that are relevant to them. So monitoring was a big piece. And apart from monitoring, we also had some user experience improvements, mainly around developer productivity. You can now run processors once. Previously, the way NiFi works is you just start a processor and then it keeps on running continuously, which is great for production. But if you're just developing something, you want to quickly test something with a few data sets, just run something once, quickly generate the data for me. It was kind of a bit of a hassle. So now we have a real first-class user experience around that. And also a feature that's been asked for a very long time in the community. Is a dangerous one, but it can also be very useful. On your high-level process groups, you can now empty all queues of all the processors and the connections that are in the child process groups. So it's a big one. And apart from that, we also introduced more than 40 new processing components. Highlights include some new Azure Data Lake storage processors. So for all of you That's a common use case we see on Azure integration with ADLS. We've improved these processors and integrated them with our CDP identity management solution and Ranger authorization control as well. So a lot there in the new NiFi release.
That sounds like it. There's a lot going on. So Kafka is becoming more and more the central message broker for customers where all of their events are going through. As a data steward, you need more visibility into your Kafka workloads and who's using them. What are you guys doing to help them get more visibility with Data Hub?
Right. So a common scenario is that you use NiFi to pick up some data from somewhere, and then you make it available to lots of downstream applications. You could send the data directly to these applications, but many times our customers just opt to use Kafka for that, buffering layer. So now, as you say, more and more data goes through the Kafka cluster, and we need to be able to do two things: monitor in real time. What's the health of my cluster? What are the performance metrics? How many topics do I have? Are my producers consuming on time? For that, we have Streams Messaging Manager. That's part of our Kafka clusters by default. So when you create a Kafka cluster, you get that rich monitoring. And the second thing, what we recently added to CDP Public and Private Cloud is the ability for Kafka to automatically create metadata in Atlas and the data catalog for all topics that users create. So topics will show up, they're browsable in our data catalog, and they will also show the data lineage. And you see a representation of that in the slide here, which means if you have a topic and any producer interacts with it, any consumer, you'd see a visual representation of that, and we can visualize that entire data stream.
Got it. That's really interesting. That sounds really useful for customers. What can we expect to come next for DataFlow and streaming on Data Hub?
So one of the things we're working on, and we also released the first part of that functionality in April, is the ability to scale up and down these clusters. As of last month, you're now able to scale up NiFi clusters, and we're working on introducing the scale down functionality as well. And we're doing similar things on the Kafka side. The challenge with scaling down in these systems is typically that they store some information, some state, or processing information that needs to be safely offloaded. So there's some coordination that needs to be going on. So that's what we're working on, what we'll provide soon. And another big item are the in-place upgrades. So upgrading your Kafka and NiFi clusters in place, that is another big item that we're working on, and we'll see in the next quarter.
Got it. That's interesting. So a bunch of exciting new stuff coming that just came in is to come. Now, Krishna, so we usually think of Cloudera as delivering a data warehouse. What's an operational database and how is that different?
So why don't we take 30 seconds and ask our audience before I respond to that question. So if you're listening in, type A if you believe that an operational database is a transactional database that stores data in a row major format, or B if you think an operational database is an analytic database that stores data in a column major format. And we'll wait 30 seconds before I start discussing, and then we'll review the feedback as well.
Got it. I'm curious to see what people come back with. Don't forget the answer, A or B.
And I'll repeat the options once again. A, if you think it is a transactional database that stores data in a row major way. Or B, if you think an operational database is an analytic database that stores data in a column major way.
So we're getting some Bs, it looks like.
Okay.
There's more Bs than As right now. Krishna, what?
All right. So let's go on to the next slide, and we'll let the answers come in, and we'll talk about it towards the end of the slide. So when we think about the operational database within Cloudera, we think about custom in-house applications that you're building to support your customers' needs or your business's needs. Kind of as an operational database, we are actually row major, like most other operational databases. But sometimes when you hear about column families within HBase specifically, you may get confused with thinking about it as a column major database. Fundamentally, an operational database is the store of record for an app or an app platform And as such, and especially in the world of big data, you also need to ingest data that may not be coming directly from an app. A lot of data will come in through apps and through customers, but you'll also have a myriad of streaming sources and batch sources that you'll want to ingest into. And you'll typically do some form of aggregation to clean up that data, to categorize it, to do some other piece of cleanup before the data lands in the database for use by the applications. From that standpoint, and we'll talk more about this in a minute, but we see customers using Cloudera DataFlow almost always. So you'll almost always see Kafka as the enterprise message bus, and then you'll see either NiFi or Spark for the aggregation layer. Spark is part of our data engineering toolkit. NiFi is part of our DataFlow toolkit. And like all operational databases, we also expect customers to do ETL from our database into a warehouse. And we have the Cloudera data warehouse as a target. And there you see customers using Spark, or you use Hive on Tez to do that ETL transformation. Similarly, we have a lot of customers that want to use our database for machine learning. And so we have Cloudera Machine Learning that's designed for data scientists to go build machine learning algorithms. However, once those are built, there are really only two ways from a data science perspective of how these are deployed into production. One is a REST endpoint, which is great for experimentation. But once you get to large-scale mission-critical applications, what we typically see is the machine learning algorithm is pre-computed into a table and deployed in the database. Once that is done, then applications can use that to do lookups, get real-time responses like they would want from anything in the database, but also the database provides the resiliency and availability needs that their applications are dependent on. So when you think of an analytic database, these are not the type of use cases you would typically expect. An analytic database is storing things in column major, so it's really good for analytics. So if you have if you have a BI analyst, for example, you're running large, complex Tableau workloads, that's where the column major format gives you much better performance. Fundamentally, row major is where transactional databases live. Column major is where you see your analytic databases, and they have massive trade-offs in performance. So you will see row major databases cannot compete with analytic column major databases for certain types of queries, and vice versa. Column major databases can't really compete with row major operational databases for the bread and butter of what operational databases are used for.
Got it. Interesting to learn about the distinction, and it looks like about half and half from our audience knew the difference between an analytical and transactional database and understood kind of what an operational database is. So hopefully this was informative for everyone. I know we're talking a lot about how we're delivering services and experiences. What's the operational database experience?
Yeah, so the operational database experience takes the operational database that Cloudera has, that's fundamentally built on Apache HBase and Apache Phoenix, but then wraps an entire service orchestration layer around it to provide an autonomous database. And what this does is now free up your developers and your administrators to do higher value tasks than just managing Cloudera's operational database. For example, if you're going to go and deploy an operational database, what used to take weeks, if not months, to deploy and secure, now can be done in 2 clicks and 20 minutes. This means if you need to deploy a database because someone wants to go build an application or they're required to build an application, they don't even need an administrator in the loop. They can do it themselves. It's as easy as selecting an environment and giving it a name and they're done. Go get a coffee. By the time you're back, you're ready to go. You no longer need to dig into documentation or dig into configurations to figure out how to connect to it. All of that information is provided up front. From an administrative perspective, the biggest hassle of using Cloudera's operational database is how big does this need to be if I have an existing application, or how do I grow it? What do I need to do to manage it as the needs of the applications I've deployed grows? All of that goes away with our auto-scaling capability that not only scales the database up as your application needs grow, but it actually monitors the ebbs and flows of the workload over the course of a day and will make adjustments to the size of the database based on the application load that's on the database. That is a rules-based engine. That's where we started. We've continued to add rules to make the auto-scaling more sophisticated to meet a broader variety of needs that customers will experience as they get on the platform. In addition to auto-scaling, we have auto-tuning and auto-healing. They're an entire class of complexities and that can rise in a database that you can't auto-scale your way out of. For example, if you have hotspotting and all of your traffic is going onto one physical node within your database, there's no amount of auto-scaling, no amount of nodes I can add that can solve that. So when you run into those classes of problems, that's where auto-tuning steps in to analyze the workload and access patterns and then remediate them on the fly. Effectively, as you run your database, without scaling the cluster, performance will get better over time as we learn more about it. And auto-healing is about how do we remediate problems that our existing operational database customers have run into. A lot of those, there is an art to managing and remediating them, and there's part science in terms of there are specific steps that always have to be done, or you can come up with a rules engine to figure out when those steps should be applied. So we're now layering in an auto admin that will be responsible for intelligently analyzing these sort of issues when they come up, and then remediating them so that our people administrators with our customers don't have to. So this is in a nutshell what the operational database experience is within CDP Public Cloud.
Got it. What do you think the feature is that you're most excited about launching as part of the operational database experience?
Yeah, so there's two that we launched that are super exciting. In addition, so when we talk about operational database, there are fundamentally two types of experiences you can get within it. If you're an H-based customer, it's an autonomous H-base. If you're building new applications, we talk a lot about Phoenix, which is our relational version of operational database. And from that perspective, our relational capabilities have gotten a lot better recently. We can run transactional workloads now with distributed cross-table, cross-row complex transaction support. That was the last thing we needed to be able to run now TPCC benchmarks out of the box. And TPCC, for those of you that are familiar with it, is basically the benchmark for operational queries and for financial queries and order processing and things like that. So it's a good way to evaluate any relational database in the world. The second piece is we just launched support for Hue, Apache Hue, to use Phoenix. What Apache Hue is Cloudera's SQL interpreter that we use for interacting with Cloudera's various different components, whether it's data warehousing or OPDB. Now that Phoenix is supported, you get all the rich flexibility of Hue, so type ahead, data browsing, etc., to go against operational DB.
Got it. Can you share an example of a customer use case of how they might be using operational database?
Yeah, so one example is a large auto vehicle manufacturer in the US. They have 200,000 plus trucks plying the roads of North America, sending data from those trucks into operational database using a combination of the Cloudera DataFlow technologies that I mentioned earlier. All of those trucks send that telematics data. Then they've got a fleet of 20 plus applications that run on this database to make sure that they can do the things that they need to. For example, real-time routing, driver performance, etc. And that data is fed back to their customers who are fleet managers, as well as to repair shops if they need to proactively do any sort of fixes or to the trucks themselves, right? Or oil changes, whatever proactive things they need to do. The focus of the platform is to make sure the trucks keep driving and plowing through the roads, whether that's rain or shine or COVID or anything else that lands in the way.
Got it. That's interesting. So then let's bring it all together. Question for both Michael and Krishna. How do you ingest data into COD, and how does DataFlow collaborate with COD?
Yeah, I think what Krishna just mentioned in that customer use case is basically what we see all across the board. So there's two ways of how people can ingest data into operational database. You can either write your own application to be able to talk to it and ingest data, or you use something like Cloudera DataFlow and specifically NiFi to ingest that data. And what we typically see customers doing is they already have some producers. So in Krishna's example, that would be the trucks actually generating that data. They might send the data not directly to the operational database because there might be other applications interested in that data. So you send it to Kafka, for example. From there, NiFi picks it up and ingests it into the operational database experience. And we've got processors in NiFi that make it really easy to talk to HBase. So with the way how the operational database experience exposes the connectivity information, the way you configure it in NiFi, it's really super easy. It works with the same centralized security mechanism as well. So the policies that you define in Ranger that are applied to the tables in the operational database, they're respected by NiFi. NiFi goes through that, so you get this integrated approach if you choose to follow, this Kafka NiFi operational database pipeline approach.
Got it. Krishna, anything else from your side that you wanted to add?
Yeah, and we really focused on the simplicity of interaction across the pipeline. So one of the cool things that NiFi brings to the table is almost 300 connectors, probably a little bit more than that, so that can connect to a myriad of other sources. So you really get really broad connectivity when you hook NiFi into OPDB to allow your platform to be much more functional in terms of the types of data you can manage and surface and use in your applications.
Got it. That's interesting. So I think we have a little bit of time for one other question. And for the audience, don't forget to ask your questions in the chat or in the comments. That way you can be entered in the raffle. And so we can also get to your questions and see what questions you have for Krishna and Michael. So Krishna, what is the schema model that we support with operational database?
Sure. There's two different schema models that we support. One is NoSQL, which most customers would be familiar with. That's just using NoSQL HBase APIs. The other that's a little less familiar is what we've introduced in CDP with Phoenix. And with Phoenix and with transaction support, now you can do relational schema. So taking what you've normally used with MySQL or Postgres and port it directly over into Phoenix. This is useful when you're moving an application that's overgrown its existing database. But if you're building new applications or you're growing those applications within the context of Cloudera, we also have support for evolutionary schema. And so just to walk through this example, if you look at the slide, the very first section talks about how to create a database. In this case, it defines two columns, ID and user, and you just created this database. Think of this as V1 of an application you're building. And then you have a set of queries against that. In this case, we just did an upsert of ID1 and user KM, and it's just there. If you do a select star, you get what you expect. Now, when you come to building a V2 of your application, you've got all these queries and all this code that exists, and you realize in V2, you now need to add another column or set of columns to capture more data. And so in an upsert, you literally just define the columns you're adding and add your data. You don't have to go back and retrofit all of your schema, which requires heavy lifting on the database itself. But when you did a select star, just another example query, what you'll see on the right-hand side is I added one more user, I see it, but I don't see the state. And that's exactly the result you want so that your existing code that doesn't know about this column continues to work as it used to work. You don't have to go back and retrofit it. On the other hand, if you look at the next line, we can do a select star this time adding in the columns that were not in the table definition, and you'll see the table on the right that includes the new data. This is great when you're evolving your schema and building an application, but it can also get really cumbersome if you have to redefine and respecify your additional schema with every query you do. And so from that standpoint, you can now define a view on top of this table that adds in the schema that you layered in that was not in V1, and now start querying that view. In this case, now you can do the select star against the view instead of the original table, and you'll again get the full table. Now with our approach on evolutionary schema, you can continue to iterate on this. So say V2, you land up with a view. When it comes to V3, you can now start layering in columns on the view just like you did on the original table. And then if that gets cumbersome in your queries, you can create a view on top of that original view that now makes it look like a table again. And then you can repeat that on V4, V5, V6, whatever. And the same approach continues, and it continues to just work. But you save yourself all of the engineering time required to retrofit all of your legacy versions of your product or all the existing code paths that work fine and don't need an update while you're layering in new capabilities.
Got it. Thanks. So everyone, just don't forget to ask your questions of Krishna and Michael. I have one more thing I wanted to share with you, and then we'll move on to Q&A. So earlier this month, we launched a new channel within the Cloudera community. For those of you who aren't already on, you should join the Cloudera community. It's community.cloudera.com. You'll get the link in the comments below. And that is where we have a lot of great user engagement. We've also launched the What's New at Cloudera channel. So if you go on there, you'll see articles from our PMs, our product managers like Krishna and Michael, about new features and capabilities, much like what they talked about today. And so those articles are constantly updated, and you'll learn more about what's new, how it can help you, and how to deploy it. So start to bookmark it, subscribe, and take a look. Let's move on to some questions. We've got some good stuff coming in. So Michael, this first one's for you.
Mm-hmm.
What is the difference between NiFi and StreamSets data collector?
Right. So when you look at NiFi and StreamSets data collector, maybe from the 5,000 feet view, they seem to be very similar, and they're basically doing the same thing, right? They're moving data from A to B, and you can transform it on the way from A to B in a certain degree. When you look a little closer, though, the way these two tools handle the requirement is quite different. NiFi, for example, is very flexible in the way it treats the data that you move through it. So it doesn't, for example, it doesn't require or enforce a schema on data. You could move any arbitrary type of data through NiFi, and it'll do it just fine. If you want to, you can add schema information, and you can then start using SQL and other query technologies to transform the data as it goes through NiFi, but it doesn't force you to always apply a schema. So in terms of the ability to work with any type of data, that is really where NiFi shines and stands out, and also the performance gain that you have through that. You don't have to treat the data record by record. You can actually treat them as bigger chunks, as bigger bulks, and that is really helpful for certain workloads.
Got it. Are the NiFi features tied to the Cloudera ecosystem, or the same feature as the open source version?
So the core features are tied to the open source community. So now we just introduced NiFi 1.13 with all the major features that the community has. But then in terms of offering NiFi functionalities in CDP, we provide additional benefits. So for Data Hub, let me give you an example. There is, if you want to interact with systems like a Kafka cluster that is secured using TLS, you need to tell NiFi where to find all the trust stores and how to securely communicate with that cluster. Now, we pre-create all these resources for you, so they're already there. You don't have to figure out how to get these trust store in place, etc. You basically just pick it from a drop-down list. That's what you want to use. So there's a lot of things we do around ease of use, but then also the integration of security and governance. So when you create in CDP Public Cloud, there is no option to create a non-secure NiFi cluster. Like, they are secure by default. And it's similar to what Krishna said. We have seen customers where it takes them 1 or 2 weeks to create a fully secure NiFi cluster based on the open source version in their own cloud environment. Whereas with NiFi and Data Hub, it takes 20 minutes and you've got a fully secure cluster ready for your developers to go.
Got it. That's good to hear. So Krishna, does operational database support external tables like Hive?
Yes, but that's a very Hive definition view of the world. And so if I flip it around a little bit, Hive has external tables that can be stored on operational database and queried by Hive. If you take it in the way the question is written, can you store operational database tables outside of the operational database? The answer to that is no. You'd lose all the capabilities of the operational database by pulling the data out. The one exception to that we do see is customers using NiFi or Hive to pre-create tables and then ingesting them. This is what we call bulk loading into the operational database. So there you can create a table outside. You can't do any operations other than really creating it. But once it's in the database, you get also all the benefits of being in the database.
Got it. Michael, is there any improvement in NiFi's load balancing in this version in cluster mode?
So would be interesting to know if there's a specific improvement you're looking for. I'm not aware of anything specific that we would be highlighting here. So there's the way, so maybe you're using an older version of NiFi where load balancing was required in connections between processors, so you can actually make sure that data is distributed to different nodes. But over several NiFi versions, that capability has been improved significantly. So you don't have to do that anymore because NiFi takes care of that on its own when it's run as a cluster. But yeah, that is the main thing I would call out, that a lot of our customers, they have had to configure things like that manually in earlier versions, but now there's no need to do that anymore.
Got it. So let's take one last question. Is the SQL ANSI SQL compliant?
Yeah, so we are ANSI SQL compliant when it comes to relational schema. The extensions that we talked about with evolutionary schema aren't in the SQL standard, but in terms of core relational capabilities, they're all ANSI compliant.
Okay, got it. So now that was our last question. So let's do our raffle. And today's raffle winner is Saurabh Tuladar. So Saurabh, if you are still on, if you could email socialmedia@cloudera.com and to claim your prize. Thank you everyone for joining. Let's join us next month for our next Cloudera What's New with Public Cloud session, and follow us on social media to ask us more questions if you have any. Thank you so much for joining, Krishna and Michael.
All right, thank you for having us, Hannah.
Yeah, thank you, Hannah.